People have asked me to cover a particular hormone known as human growth hormone, so I decided to take some time and read through a scientific review of the hormone covering how it functions, differences between men and women, what raises HGH levels, and some complementary hormones that affect HGH. So if you're a person who would like a concise education on the hormone, I will provide it right here, right now.
Learn Your Body, a science-based education.
The information I'm covering is mainly being sourced from a short scientific review that I will have linked for you, along with my notes and any following amendments. HGH, GH, or its full name, human growth hormone, is a hormone secreted from the pituitary gland that is associated with the growth of cells, regeneration, among other cell survival effects, as well as more whole body physiological effects like promoting fat breakdown. Many of these effects are done indirectly by increasing levels of insulin-like growth factor, or IGF. That is then secreted from the liver, although other cells generate IGF as well. This interplay between growth hormone and IGF is known creatively as the growth hormone IGF axis. Yet, growth hormone has some unique characteristics about it. First, it is released in a pulse-like manner, releasing, then falling away, then releasing, then falling away, and so on. Sex hormones like estrogen play a role in regulating growth hormone levels, and this is evidenced in the fact that women pulse more growth hormone than men. And while sex hormones affect growth hormone release and synthesis by the pituitary, there are more applicable effectors that also play a role, like fasting, low protein consumption, and calorie restriction all increase growth hormone levels. In line with that evidence, obese individuals tend to secrete less GH through fewer and less pronounced bursts of the hormone. Interestingly, this effect is partly reversed, meaning greater bursts of GH when a person undergoes weight loss from an overweight situation. Another important factor is sleep. Sleep, especially in deep stages of sleep, 3 and 4, release large amounts of growth hormone. So impairment in sleep leads to growth hormone secretion impairment. This is also evidenced in comparison to REM sleep, or lighter sleep, where GH release is lower than in deeper sleep. Now, that tells us a quick overview of GH, but it fails to consider two of the regulatory mechanisms for GH synthesis and release. Growth hormone is controlled by two other factors, an inhibitory and a stimulatory hormone. The inhibitory hormone is called somatostatin, or growth hormone inhibiting hormone. Somatostatin is released by a variety of tissues, but the hypothalamus of the brain is one of the nearby sites to the pituitary. Once somatostatin is released, also in a pulse-like fashion, it binds the pituitary, inhibiting growth hormone. This means that when somatostatin pulse is high, growth hormone pulse is low, and vice versa. This is the inhibitory hormone. However, low somatostatin is not the only prerequisite for growth hormone release. Rather, growth hormone releasing hormone, GHRH, is also needed to stimulate the synthesis of growth hormone. This stimulatory hormone also comes from the hypothalamus of the brain. Meanwhile, IGF can then feed back and stimulate somatostatin release, creating a self-controlled loop between the hormones. So I hope this information proved informative, and I certainly will cover this in far more detail in the future, but for now, I simply hope you found this useful, and I hope to have the pleasure of speaking with you in the future. Cheers.